Test. I see some people are slowly but surely joining us in the session. And this is the first time that I'm doing a webinar, so let me know if you don't hear me in the chat. You don't hear me? Okay, perfect. Thanks for letting me know, because my colleague who's sitting across from me outside of the phone booth doesn't hear me, but I think it's his headset. Though I will wait for one more second and then I think we can get started. Seeing some familiar names in the chat, so that's nice. Thank you guys for joining. I guess while everybody's dripping in, I'll already drop a poll to see what sort of people are joining. Just lost sound check. Cool, if you can hear me. Can you close the door? Okay, perfect. Then we'll get started while you guys drop some responses in the poll. I guess also a general question from our side. We would love to know just in the chat what you hope to learn, what you expect from the session today. We hope to share a little bit more about how we think you guys should experiment and approach evaluation in a systematic way using Orq or any other platform, actually. So I'll share my screen. You guys can see my screen? Because now I don't see you guys anymore. Kuldeep, can you see it? Perfect. Okay, so the session of today, Master AI Model Evaluation with Orq.ai experiments. So what I hope to discuss today is how we think about experimentation, some general key learnings and takeaways you can hopefully integrate and adopt in whatever workflows you already have, whether or not you're using our tool. And obviously also show how you can do the testing using Orq. Today we will have focus on really our experimentation feature in the UI, but we will host a separate session in a few weeks where we really will go into sort of CI/CD type of testing for AI features. So why are we here today, and why do you want to have a systematic approach to experimentation? What we see in our customer base is that the teams that really dedicate time, really dedicate resources, if it comes to creating and building evaluators, spending time on experimentation, that they achieve way better outcomes. And they build way more sort of stable and reliable features. But obviously that also comes with reporting more incidents, because as you start to measure more, you report more incidents. So it is, what I think is most important takeaway for today is the moment you start with experimentation and evaluation, you do not just let it run, but when you find things, you act upon that again. And you build another data set, you build another evaluator, you run another experiment to go deeper and deeper into your problem so that you eventually really filter out a lot of issues that might occur building with probabilistic systems, as probably all of us or most of us are in the call today. So yeah, teams with systematic approaches to evaluation report more problems, but because they just have way better measurement structures, they reveal issues that other people miss, which allows you to actually build a system that is far more robust in production. And what we're seeing in our customer base is that the people that actually have dedicated FTE to sort of building evaluators, or a new buzzword in the sector is eval engineering, running experiments. They build features in productions that really get to, like, I would say high up in the 80-90% accuracy level features. Whereas what we see with the other teams who just try to wing it, they get stuck maybe somewhere around high up in the 70s or 80% accuracy range. More about that word later. Assuming low risk backfires. Risk assessment requires measurement. You can't do it on intuition. I know we all started with vibe checks. I think vibe checks can get you a long way doing your first iteration on prompt engineering. But as you all know, even if you ask the same question 20 times to a model with temperature set to 0, you won't get like the perfect identical response 20 times. But it is what you need to know when you are really going to run systems in production. You need to know, okay, if we ask our 100 or 1,000 most asked questions, how well does the system respond? If we ask 1,000 outlier questions, how does our system respond? How do we need to tweak it? How do we need to tweak the agent instructions? How do we need to tweak the tool descriptions to make sure those queries do get responded properly to, or this input data does get handled well? Obviously, there's many ways of evaluating. I think today there will be a focus on AI evaluation, or LLMs as a judge. What we always advise our customers is anything you can evaluate in a deterministic way, please do so. But using LLMs as a judge is a very powerful method, but obviously, just like any sort of LLM, it has a consistency problem because it's not deterministic, but it's a probabilistic system. So you do not want to avoid this form of evaluation, but you need to be rigorous with your eval and engineering cycles, which literally in the core just means, okay, we're going to free up time and resources for people to work on this. Because what we see in our client base is that the people that are most diligent, they test every single AI feature. So if they have a multi-agent, every single sub-agent gets tested separately. The multi-agent gets tested end-to-end. And they also test every single eval on a data set to know how will this evaluator behave with this model, with these parameter settings. So a lot is about putting in the work. And that's, I guess, the last block. Culture creates results. Not to sound like a consultant, but it requires somewhat of a culture shift to free up this time and free up these resources. So quickly to set the context on sort of how we look at the software development lifecycle and how we think this fundamentally changes when building AI features. So we did a small iteration on an abstracted version of the software development lifecycle. We abstracted it to 5 steps. So the first step is plan. That is not any different from building a classic software product. That's where you spec requirements. That's where you define success metrics. That's where you discuss all the potential risks this feature might be exposed to, how you will build it, what you will use. The only thing that is super, super important is the depth of these requirements and the depth of the definition of quality of your AI feature. Because if you don't define that in step 1 of the planning phase, you won't have any good basis to test on when you get to step 3, which is the experiment phase. More about that in a bit. Then second is build. So build is actually split up in sort of 3 different blocks. Somebody needs to take responsibility of the back end, somebody needs to take responsibility of the front end, and now somebody in the team needs to take responsibility of the natural language component. Whether you build a simple AI feature where you do a single LLM call, whether you build a multi-agent, somebody needs to write the agent instructions, somebody needs to write the tool descriptions and needs to test those. And that's what you do in our experiments feature. In the third block, you start testing your setup that you engineered maybe with going back and forth 20, 30 times on a curated data set. Before you go live, that is where you find your optimal configuration. And after go live, that is where you do your regression testing, that is where you do your A/B testing. This is also the step that we less and less, but historically saw a lot of people skip. So a new model came out, we went from GPT-4o to GPT-5, we had a client switching from GPT-4o to GPT-5 overnight in production, and the performance of their feature went down by 20%. This could have easily been prevented if they would have run probably a single test, because they would have seen that the prompt that they were using for GPT-4o was not adjusted for GPT-5. After you found somewhat of an optimal configuration, obviously it's always local optima. If you, I guess want to have the academic discussion, you go into the deploy phase. And it's really in phase number 5, operate, where the work starts. So that is where you need to have somebody dedicated looking at what production data is coming through your system and how your system is behaving. Is your agent responding the way you like it to respond? Is it retrieving the right tool calls? Is it performing okay on cost? Is it performing okay on latency? And it's also from operate where you want to gather the data sets, because ideally you want to do back testing on edge cases or your golden truth data set on real life data that is as close as possible as to what the users of your product send to your system, whether that's customers of yours or actually internal employees that are using your product. So we see sort of 5 levels of evaluation intelligence. So what I just mentioned, almost everybody starts at level 1, vibe checks, siloed manual reviews. You can get to an okay first version of performance, but you will never get, I would say, to like above 75% reliability. Well, then you have systematic human review. Somebody in the team got the task to look at least 50 logs every week to see if anything weird happens, to monitor the performance. And then you have level 3, exploring AI-assisted evaluation. And that is where we will focus on mostly today. How can you sort of make the first push to setting up a process, setting up a system to test the config that you want to put live initially and to test the config for every single update you want to make in the future. Whether that is changing a prompt, whether that is changing a model, whether that is changing a parameter, you want to have a way of working and a tool that makes your life easy so that you can run some of these tests in minutes rather than hours. Then level 4, scalable automated evals and human-assisted feedback. So this is also where we see CI/CD sit. Like I would say in our customer base, we see some customers who have CI/CD type of checks embedded in their pipelines to check on their generative AI metrics, and also have like proper processes set up where not only evaluators evaluate traces or logs coming in, but also dedicated humans perform annotation on these data points that they then again feed back into the data set. But this topic the human annotation we will touch upon today, but the real sort of scalable automated evals in a CI/CD type of way, we will discuss in a few weeks from now. And then level 5, actionable evaluation metrics that auto-adapt for you. Yeah, that is almost self-learning, self-improving evals. I would even say before this, you probably want to explore the route, especially when you have products that run at scale, of perhaps fine-tuning models to get to higher evaluation result levels. I don't see the Q&A, but are there any questions in the Q&A? I'm looking at my colleague. No? Then I continue. So, as I mentioned in the beginning, you can only run a good experiment if you are diligent in phase 1, which is the planning phase. That is where you really lay the foundation for a successful AI or Gen AI build. and I know it's obvious, but I see it go wrong too often. So this is where you define your success metrics, define clear measurable outcomes. This is where you ideally also already start to think about your data prep, before you go live. Okay, do we have data that we can already test this feature on real life data from our customers, from the manual processes that we have, maybe even already annotated data because a human used to do this task that we can test against. Like, we even speak to teams that only build AI features for which they have already annotated data, so that they actually can benchmark and measure the performance against real data rather than only sort of synthetic data that they might generate and check. And obviously this is where you do risk identification. So some of you might be in regulated sectors where you cannot give medical advice, you cannot give financial advice. Even ethical risks matter more, whether there's like bias captured in the models, where people from a specific gender or specific background are preferred by the model just because that's captured in the data. You want to write all of this down in as much detail as possible, because this is what allows you to later then build evaluators and also select the relevant evaluators that you need. We often see, obviously, as with a classic software product, that a product manager is responsible for this, but we also see that we can highly advise it sort of that you involve subject matter experts, because we are a platform that has been built out consciously with the idea that you build the highest quality metrics if you let technical and non-technical people collaborate. And for many of the AI features that are being built, a lot of the domain knowledge sits in the heads of subject matter experts. So if you already involve them in this planning phase, you will build better evals later. So quick do's and don'ts overview, also what was just mentioned, clear measurable metrics, involve domain and data experts. Yes. Question, let me check. So, wait, I will stop sharing so that you guys don't see all the reflections or the tunnel. So there's not really a one-way answer. What I see, to build good evaluators, you need to build custom evaluators for any use case. And that's, I think, why I stress it so much, that you need to spec good requirements. And I'll show you guys an example in a bit, but you need to be as detailed as possible, because the more detailed you are, the more detailed of an evaluator you can write, whether that's an LLM-as-a-judge, whether that's a Python eval, or whether you build an entire system that you expose via HTTP. So good success metrics, is really use case dependent. But if you ever want to spar specifically about your use case, we're happy to jump on a quick call. And maybe for the generic ones like cost and latency, obviously that very much depends on how the people or how the user interacts with your product, So with latency, you can set benchmarks and work within those benchmarks. With cost, it depends, is your system being requested 1 million times a day or 1,000 times for a human task that was historically €5? No, I will share the slides now again, because that's why you don't see them. Obviously, but this is, I guess, standard. Validate the business case before building anything. Identify clean and critical data sources, and then potential risk and plan mitigations early. This data obviously is very, very important once you get into step 3. Well, we'll get to that in a bit. So this is a very sort of simple use case that I've built out for today, and this is probably not at all the level of depth that you need to go even deeper than this when you guys start building out your own features. But what I'm going to show you today is a very simple comparison between a single agent and a multi-agent build in Orq. Both of them have access to the same MCP tools. One is Fireflies, which is our meeting transcription tool, and one is Linear, where we do our project and product management tasks. And what for me was very important, that I only want the agent to reference meetings and tickets that actually exist, that I wanted to always do accurate forms of source attribution and actually cite the ticket or the meeting reference, that it directly addresses the question asked, don't go off topic, that I don't want extremely long answers, a maximum output of 300 words. We have a team that speaks a range of languages. The main language is English, but I want the system to respond in the same language as the question and to give good answers in English, Dutch, and Spanish. And I want it to respond in the correct JSON schema. And why I have at the top, what does high quality accuracy mean for you? To just write down, we want to have an agent that responds with a high level of quality, doesn't say anything. You need to go really, really deep on what quality means for your use case, and that can be like amount of words, that can be the exact format of the title, that can be the exact order in which the description of whatever you're outputting needs to be given, that can be adhering to the business tone of voice. It's all of these things that together make up high quality and accuracy. So when you write this down, you always need to think, okay, this high quality accuracy sentence needs to be split up in at least 4 to 5 things to make it actually measurable and actionable for us. Phase 3, experiment. So an experiment pretty much consists out of 2 core components: evaluators / guardrails and datasets. And both of those 2 things need to be developed properly for you to actually extract relevant results from the experiments that you are running. So ideally, before you start testing your feature in a parallel process, you optimize your evaluators and guardrails separately from your actual features, so that you know, okay, this guardrail that needs to check for tone of voice is actually really good at checking for tone of voice of the copy that we write or that we output using other features. So quick refresher, just to make sure that we all are using the same lingo. What is the difference between a guardrail and an evaluator? So today we will focus on experiments, which some people would call offline evaluation. There we mostly use evaluators. They run asynchronously if you run them in production, so they don't add any latency to your transaction. They simply just show you what is happening and what sort of data is flowing in and out of your system. And then guardrails can actually block transactions, and that is the flow that you can see here. So you can have an input guardrail that does a form of PII detection. If it detects it, it blocks it, and nothing is actually being sent to the model provider. Or you can have an output guardrail, even for tone of voice. If the output guardrail doesn't adhere to tone of voice, doesn't hit a threshold, it gets blocked. An evaluator just tells you this doesn't adhere to tone of voice. So this is probably one of the, question. So no, our platform includes user level feedback, and I'll show you in a second what that looks like. So you can do human annotation both on offline experiments as well as on production systems. Yeah, even your users. So we have something that is called the feedback API. Maybe my colleague can send it in the chat. And that you can use to integrate what is happening in your front end, so that your users can give direct feedback on the transaction, and we map that in the traces so that you can also, again, build data sets on that. And for example, build a data set on everybody that deleted the output that you gave them, or build a dataset on everybody that copied, or just a thumbs up, thumbs down, whatever you want to expose. So some simple do's and don'ts when you start building evaluators and guardrails. We still, for the teams that are starting out, recommend to output Boolean values where possible, just because most of you probably know this by now, but these models are just biased to go to specific, when you use numeric values, to go to specific numeric values. They will always sort of converge on a scale from 1 to 10 to 7, 8, maybe even 9, 10. On a scale from 1 to 5, they will converge to 4 or 5. So you really need to clearly define and explain your evaluation categories. And when you use numeric outputs, provide really clear scoring criteria. Like this, explaining your evaluation categories, whether you're using Boolean or whether you're using numeric, will make all the difference if it comes to building good evaluators and guardrails. Then, as with any sort of LLM tasks, the smaller you make the task that the model needs to focus on, the more consistent the output. So if you can, especially for testing, I say, if you can split up the different things you want to check for using an evaluator, then it's better to split them up. So if you want to check for language, for example, has the right output language being used given the input question that was being asked, and do you want to check for tone of voice? Yes, you could write an LLM-as-a-judge that checks for both, but you will get to higher levels of accuracy if you separate them. Then, as with normal prompting, few-shot prompting will improve the output of your systems. I think adding up to 5 examples can significantly improve the output of your system. Obviously, also there, it's important that the examples that you provide are balanced. So if you have a Boolean value that needs to decide whether something is medical advice or not, but you give 5 examples where it's every time not medical advice, it's very likely that your evaluator will return the negative output more often, because that is what your 5 few-shot examples are about. We automatically, when you use evaluators in Orq, we automatically output or force the model to reason about the verdict it gives, or before it gives a verdict. If you use any other system to build this, you should build this in yourself, because this will heavily increase the performance. Another thing we do automatically is to use structured output, but also this is something we recommend if you want to improve the reliability of your evaluators and guardrails. And then one of the other findings that we found building together with some of our current clients, that if you have really specific safety requirements, because again, you're in a regulated sector, so you really don't want it to give any form of financial advice, for example, and you really don't want it to mention very specific information or very specific sentences. It's better to very explicitly and extensively include this in your system prompt, because filtering this out using guardrails on a production system will be more expensive and way less good. So we see, if you really talk about implementing safety in production systems, your most important guardrails should probably be mentioned in your system prompt as well. And that obviously also has a positive effect on cost and latency. How do you go about choosing different models for prompt generation and judgment? What combinations works best to remove preference bias? Yeah, that's a good question. So the best is actually to use a mix of models, I think, at least for the things where you can use a mix of models, like dataset generation. Like what we tend to do, but there's more advanced ways of doing it. But if you just have a single evaluator running on your production system, then you use a different model from a different model family to evaluate that system. So if your feature is running on GPT-5, then you might use Anthropic to evaluate. If you want to go more advanced, but also spend more money, then you can have what you call a jury. So for example, you can have GPT-5 be the feature, and you can have a mix of Anthropic, Gemini, I don't know, maybe another model you can use, Kimi K2, that all do the same evaluation, and you look at the jury results, and then you can again make a decision. Okay, do we go for a majority that we then decide? Okay, 2 out of 3 models say that this includes medical advice, so then we block it. That is the more advanced way, but that is a far more extensive way. I think the most important thing is to just remember, whenever you evaluate, you use a different model, or a different model family than what is on the feature. What will be the suggestion if the feature is running on multiple providers as part of the fallback workflow? Yeah, good one. I mean, that is specific. I don't know how often the fallback gets triggered. I would make sure that the evaluator is at least different from the primary model that is being used. And if you build a complex workflow, you can also make the decision to have multiple, do evaluation on every single node or every single step of the workflow separately, and make sure that that always happens with a model that is not identical. And if you do end-to-end, if you want to be most diligent, you use a combination to mitigate some of this bias. So that was also a little bit on the don'ts already. Using the same model for both prompt generation and judgment will give inflated scores due to preference bias. So I think the only place where it makes sense to generate your prompt with the same model is when building a feature, just because most of the models generate better prompts for their own model family. But the moment you start generating data sets or scoring, try to use a different one or a mix. And then another bias you have to be conscious of, especially using numeric evaluators, is verbosity bias. So evaluators are just very, very likely to give a longer output a higher score, because they have the feeling, okay, a longer output contains more information, even though a lot of the information that is often in a longer output is not relevant. Then some data sets, do's and don'ts. I believe there were also some AI engineers and data scientists in the meeting, but it's very important that when you start building data sets to run your experiments over, you try to find a balanced representation of the data. So if you have like a golden truth data set that you always use to run regression tests against, make sure that you also continuously update this data set, right? That this is like a living entity, so that you have indeed sort of 80% of your most occurring input included, but you also have all your important outliers included. And that if new edge cases come in that are interesting, you add them manually or automatically to the data set, but that it's not static, because that's, especially with golden truth data sets, I think it's very important to approach this as a living entity. And then another thing that can be very valuable when you run into issues in production or in testing is to create distinct data sets for each, well, obviously for each feature, but also for each issue that you want to test, so that you can drill really, really deep on that behavior. But probably after you did some of the optimization on very specific problems, you also want to rerun it again on the golden truth data set. This you probably have heard more often, but use annotated golden truth data. At some point in time, a human just needs to go through the labor of annotating a data set. It doesn't have to be a gigantic data set. We have teams testing with data sets as small as sort of 30 rows. Obviously, the bigger the data set, the safer your conclusions, I would say. But for any feature you build, make sure that you at least have a small data set where a human has checked the answers and a human has said, okay, these are good answers. This is what we would ideally want the model to output, because then you at least have something to benchmark against, something to optimize your prompt for. And again, sort of coming back to step one, the planning phase, it's so important that you write down the requirements, because based on these requirements, you can also curate your data set. So if you want your system to be robust across languages, you need to cover different languages. If you want your data sets to be robust across different input types, you need to cover different input types. If your system needs to be robust across output length, you probably even need to ask way more complex input queries that would trigger the model to give way longer answers to see how it responds to that. So everything you write down in step one will form the basis of how you will build your data set and your evals. So I would say 95% generate synthetic data at some point in sort of the experimentation process. Probably that's like where most of them start, because a lot of the teams that we work with have sort of full product teams. So you have a PM that does some of the experimentation, or you have a data scientist that does some of the experimentation, or like an AI specialist. And sometimes for them not to be blocked, they already, so that they don't have to wait for somebody to write a query to get the real good stuff from a database, they generate whatever they need synthetically already. But all the teams that are like really mature in their setup, which I think from our client base is like anywhere maybe between 40 and 60%, they use real life data, and somebody, if you don't have a data scientist or the AI engineer doesn't have time, it's often the PM in tandem with the subject matter expert who does it, or we even have teams who send data sets to subject matter experts to do some of the annotation for them. So 100% I would say generate synthetic data, and 40 to 60 uses also a lot of real life data to test against. Yeah, same thing as what I just mentioned. Do not use the same model for dataset generation and evaluation. Again, verbosity bias. Don't test only on polished examples. This is actually also something I see more often with the people who rely heavily on synthetic data. But your users will ask weirdly formulated questions with a lot of typos that you can barely read as a human. Those should also be part of your data sets, just for you to have visibility on the behavior of your system. Obviously, it's hard to tweak a system in a way where you need to accommodate questions that a human can barely understand, but then at least you can add things to the prompt if you're building something conversational that asks very specifically for clarification and the relevant clarification questions to your customer or end user, so that the system can continue properly with enough information. And then another thing is, do not rely on averages alone. Actually, I would say our most mature teams are also very focused on standard deviation. So the smaller the standard deviation is of your system, so the more consistent your evaluator outputs a specific value. Let's say you score tone of voice and you run that evaluator 3 times, and 5 times it outputs 5, and you agree with that as a human. That is more important, that when you tweak it, it seems to get a higher average on all the data points, but actually in standard deviation it's decreasing. And also what I just mentioned, check performance across subgroups. So especially when you're not happy, drill down why. Is it a specific sort of set of input queries or input variables that the system is not performing well on? Is it a specific language? Is it a specific length? Always try to drill down, because that's the only way to get to the core of it and to actually perform or improve the performance of your system. So I just quickly wanted to show you guys the front end of the use case we will now dive into in the last 20 minutes. This is a single agent I'm invoking. I'm asking it a question about the status of the assets API for the control tower. And then here it gives the response of where we stand with the development of it. So today, what we're comparing in the experiment is a single agent versus a multi-agent. And the reason why I wanted to compare it is because, it's a relatively simple agent. It doesn't have access to too many tools, even though it quickly adds up. And I just wanted to see, okay, how do these things differ in terms of latency? How do they differ in terms of cost? Maybe because, in a way, the cognitive load of the multi-agent is split better across the sub-agents. It performs better on the task. So for the single agent, it has access to 3 different tool sets, I would say. So it has access to current date time. It has access to all the Fireflies tools, which are together, I think, 8 separate tools. Fireflies, again, just for you guys to remember, is our transcription tool, and then it has access to around about 30 linear tools. Linear is like Jira. And then for the multi-agents, we have also current date time. We have the Fireflies tools, but they hang under a specific sub-agent that is called the meetings agent. And then we have, I think, something that is called like the product management agent, which is a sub-agent which controls all the linear tools, the 30. And the only thing the multi-agent has to do is to decide, okay, I get this query, should I send this to this agent or to this agent, or does it need to pass both before I can give a relevant answer? And then now, our actual experiments feature. So with the time left, I will dive right into the experiment. But what I mentioned in the beginning, an experiment always starts with a data set. So if you run an experiment from the UI, if you don't have sort of the technical skills to kick this off from code, the first thing you do in Orq, for anybody that already has access to the platform, is you make a project. And you can make a project via the sidebar here. And then you can add entities. If you click the plus button, yes. Oh, wait. Thank you for mentioning. Is this better? Perfect. Thank you guys for mentioning it quickly. So if you click the plus button here in the sidebar, actually I will make it a bit bigger, like this big. You can add an entity, and the first thing you can add is a data set. So I already added 2 data sets. Here I have, actually for this use case, I have synthetic data, where I have a bunch of questions that you can ask to the product management agent. What is the status? The question that you saw in the example. What action items came out of the HubSpot setup meeting? Are there any bugs related to experiments? I also have the source ID pooled. I also have the source type, and I have the language. The other data set pretty much holds all the same things. The only thing it also includes is it has questions in different languages. So also in Spanish, etc. Then we have another column called the expected output column, which is the column where we have the annotated human examples. So on this question, what's the status of the assets API for control tower? Here's the expected output. It should refer to this ticket. Ticket is currently in testing. this person created it and this person is assigned at the moment. I then go into the experiment. This is the right one. When I open up an experiment, we will always force you to select a data set because that is where it starts. And then the configuration of the experiment happens here on the left side. So there are, well, here's the data set, product agent, QA pairs. There's always a few things that we will measure for you. So we will always measure cost, we will always measure latency, we will always measure time to first token because many people have interfaces, like conversational interfaces where it matters. You can drill down into input tokens, output tokens, reasoning tokens, and total tokens. And then here you can configure tasks. So there's different tasks you can configure. You can compare single agents, multi-agents, but you can also compare single nodes in a workflow, for example. But the experiment today is focused on agents. And then we have several evaluators that I've written to help us check the assessment that tie back into the requirements that we've set in the beginning. So I want to make sure that the agent always cites the sources. So for that, I wrote a Python eval with several regular expressions. I can quickly show you guys that always checks, okay, is there a linear ticket ID mentioned? Is there a Fireflies meetings ID mentioned? And or are there any other sort of keywords that should trigger this? Because this is a Python eval, you simply select the output type, number or Boolean. And if you would want to run this on a production system, you can enable the guardrail configuration. Oh wait, you guys are not following me. So this was the evaluator that I wanted to show you guys. But we can share all of this information for you. Maybe for the engineers in the room, everything that I'm showing you today has been created via code. But if you don't feel comfortable using code, you can create all these things via the UI. And what I mentioned previously, so here you can configure the guardrail so that you can use it. Yes, question. Do you still see the experiment? Oh. So this is the Python eval. And then if we go back into the experiment. Oh, again. Now it's big again. Thanks for flagging. And I've built another evaluator, product agent relevance, that does a relevance scoring. Do you guys follow me? Do you guys see the new screen? Yeah. Okay, so I quickly wanted to ask you guys to drop in the chat what we can do to improve this LLM as a judge. What should we add? What can be tweaked to the prompt to make this LLM as a judge better? Well, some of you are thinking about it. Here on the left side, you can pick the model that you use for your evaluation. So I run both of my agents on GPT-5, but I'm using Claude Haiku 4.5 to do the evaluation. And I have the output type number. For the people that want to use Orq after this webinar, just quickly want to highlight, these are the variables that you can use to evaluate all the different subcomponents of the output and the input that is part of invoking a model. And the additional thing you can use is always the same input variables that are part of the data set as well. So the other evaluators, I have an hallucination one that simply checks the output of the model against expected output. How much more information has the model given than what is in the expected output? How much less information has it given? And then I do a word count to not have too verbose answers, and also to have something that is slightly more tangible than just output tokens. And then last but not least, I have human reviews configured. So I can have multiple human reviews configured for multiple people in the team to annotate the results of this offline evaluation experiment. The first thing I look at when I run an experiment, and actually just for context, I will quickly show you guys what the agent looks like. So this is the single agent. Here you see the agent instructions. You are a product agent with access to meeting transcriptions in Fireflies and project management in Linear. This is what your capabilities include. You can search and summarize meetings, extract action items, create update, cross-reference. These are simple versions of flows that the agent could go through. The more complex of an agent you build, the better you need to write out some of these flows to improve performance. Yes, the tool is hosted in Europe. Actually, our SaaS product is hosted in the Benelux, or even in Belgium and Netherlands on GCP. So I did not evaluate these evaluators, but normally you should. And indeed, make it multi-shot, make it Boolean, all very good suggestions. Then here in the user message, I give the question. So for the people that want to start testing afterwards, this needs to be mapped identically to the name of the input variable of your dataset here, which is questions. And then here I've picked my model. I've picked GPT-5. These are all the different models that we have available that you can use if you want to. If you guys start out on the free plan, you do have to bring your own keys to use them. And this is where you can set the parameter settings. So I did my first test run using text with a medium reasoning effort and verbosity low. And then here is where you see all the tools. So these are all the linear tools that you can see. Scroll down, down, down. And then here are the Fireflies tools. So here, in a way, the classification task or the cognitive load on the single agent is a lot higher because it needs to pick from a set of 30 tools what it will use. Whereas the multi-agent, the orchestrator, just has to decide, okay, this is more about meetings and this is more about tickets, or I need to use a combination. But the thesis very often is that multi-agents, you can spread the cognitive load between the agents better and the performance can be better. But obviously, you need to test it. That's why we run this experiment. Yeah, so we have caching on our online on like the agents that you push in productions and the deployments that you're pushing in productions. And we are currently working on the feature to do caching on an experiment. Because we have teams that run a lot of experiments. So the first screen I dive into when I run experiments for myself or I run experiments to clients is the review screen here. And we have that in two ways, and I will actually make this smaller. Can you guys see this properly? So here on the left side, we have all the input variables. I don't care about many of the input variables. I care about the question. And then here at the bottom, we have expected output. And here I can see a side-by-side comparison of the behavior of these two agents and which tools they have called. So here I both see, okay, the identical question is being asked. If you would want to expand it, you can see the exact difference between the two between the two agent instructions of the orchestrator and the single agent, and then I scroll down. Okay, the orchestrator first retrieves the agents. Makes sense, that's what it needs to do. This one starts listing issues already. And it tries to find if it can find any issue in linear with the query assets API. Then it, in parallel, kicks off a query that needs to check, okay, is there anything with the control tower? Whereas here you see, okay, this is the initial response of retrieving the two agents, because it checks which agents do I actually have access to. But then if I would actually look at this output for a client to check if quality is good, the first thing I do is to scroll all the way down. So I look here because the single product agent did many more tool calls actually than the multi-agent to get to its final result. I check, okay, what is the final verdict of this agent and is it any good? So I use the evaluators to help me sort of speed up this process and scale this process. So in terms of relevance, the LLM-as-a-judge states that both are good. But what I see here at first glance is that it gives me a lot more information than the expected output. It's harder to get through. Well, it uses a lot of M-dashes. Maybe you don't want to have that in your output. So, and then I check the multi-product agent. Okay, it's even longer, even more information. And that's why here at the bottom, I now annotated it with partially answers, but misses key aspects. I should probably also add a category like, yes, the relevant answer is in there somewhere, but it's not like to the point at all. And then you can go through the next one and see, okay, how are these two different? This was the question, what action item came out of the HubSpot setup meeting? Okay, Cooldeep provide mapping of intent signals to HubSpot by tomorrow. Mark fix deal source sync issue and import historical Stripe invoices. Thomas review HubSpot workflows and follow up with Cody on common room integrations. Well, this, at least in terms of content, seems relatively close together. And also in sort of initial output form generated, all the to-dos for Cooldeep, all the to-dos for Mark, all the to-dos for Thomas. Here, it looks a lot more messy. You need to add a lot more detail probably to the type of output you want of this agent to get it into a nice format that is actually readable for whoever needs to process this information. But also there again, you need to see this behavior with your human eyes, with this level of detail to know, actually we probably need to write an evaluator that starts checking for some of this so that we can just very quickly see, okay, the multi-agent is not performing well on the output form, not even the tone of voice, but literally sort of interpunction it's using. Because if we just look at relevance, both score a 5. Both score a 3 on hallucination, most likely because they output way more. As I mentioned, we always force models to reason, so that you can see here. Here you see how the LLM-as-a-judge came to this answer of 3. So the response provides extensive action items, specific names and details, but the ground truth reference is minimal and only mentions 3 core action items. And then it starts comparing. Let me understand the questions. Both results are passed. If one fails, how can you easily find where the issue is? I mean, you always have to drill down into the behavior. And true, it's not an overall pass, if that is the question. So this comes back to the beginning. We check for very specific things. So we have a Python eval that just checks, are there IDs mentioned? Probably you want to have ideally an HTTP eval running that also does a check, does this ID even exist? Because these are also typically things when the task gets hard for the agent that it might hallucinate stuff that doesn't even exist in linear. If you want to send this to an internal or external annotator, you can also have this single review screen where you see only the output of the single product agent. You are not biased by the results of the evaluator. And the subject matter expert can just check, okay, I used to be the one that retrieved this information for the PM. I'm a junior PM. Is this actually a good answer to the question being asked? Yes or no? Okay, this directly answers the question. Directly answers the question as well if I go to the next. And you can easily navigate through this annotation queue, and with this annotated data that is visible here, so here you see the annotated examples, you can again build a data set on top of that and use an evaluator to run over some of this data that you acquire here. Another very valuable screen to go through this assessment process faster, and sorry, we're going to go 5 minutes over time, apologies for that, is these heat map views. So here we're testing a single product agent and a multi-product agent, but what we're seeing here is actually that the single agent is way more expensive than our multi-agent. And that's most likely because our multi-agent can get to the end result way faster in a lighter way. However, in terms of latency, we do see that the behavior of the multi-agent seems to be a lot slower than the single agent. And then we go into relevance. So seemingly, it is the case as if actually the answers in terms of relevance are way better from the single agent than from the multi-agent. Here we have an example where it didn't perform so well. We can drive deeper into what was actually evaluated. So here we see the not amazing relevance response that you guys will improve when you start working on it. And then here we see the actual question. Are there any open bugs related to experiments? And then here we see the response of the output. You might not agree at all with the final score and the final verdict that was given. And this is exactly the reason why you need to run experiments solely for your evaluators, to prevent this from happening when you test your actual feature. Yes, you can also see the comparison of the token usage per request. Let me enable them. So here we can see that there were actually a lot more input tokens consumed on the single agent than on the multi-agent, which is probably also the reasons for the cost. We see in terms of output tokens, probably because they both use GPT-5, they are sort of similar. Both of them are set to the same reasoning levels, so that is also not strange. That seems very similar. And then here we have a total tokens output where obviously because of the input tokens, the single agent is performing a lot worse in terms of cost, if that is important for you. Then here we have the product agent hallucinations that checks for, okay, which sources do you use? Are there sources there? This is an LLM-as-a-judge. A Python check. The Python check obviously doesn't reason. And just an additional sort of verbosity check that we run here. So we do see that on average, the multi-agent is slightly more verbose, but it's still far below the limit that we set of 300 words on average. And then here, if you would have filled this in completely, you can very clearly see what the distribution is like, which model actually scores the best on directly answers the question category as viewed by a human annotator. And this is how you run an experiment. And the reason why we give so much freedom if it comes to setting up your evaluators, whether you want to look at cost, whether you want to look at latency, whether you want to look at input tokens, output tokens, all the different flavors, is because it differs per use case. And it has to differ per use case because otherwise you're not testing properly. And yes, you will have evaluators like tone of voice that might run across all your features, but you need to be specific. And it also depends per use case how you weigh these values. So there might be use cases where you care a lot about cost and latency and you actually don't care so much about the cluster of evaluators that make up accuracy or that make up reliability for you. You save so much human time that you are okay with performance levels of 75 or 85%, for example. But there are also use cases where a single LLM call is allowed to cost €1 and can take 3 minutes because a human was taking 5 hours to do the same task and costing 5 times €50. So depending on how you weigh these things, you need to go through these results and make an assessment of what seems to be the best performing entity that comes out of this. And we are currently working on an agent in our product that will help you ask these questions, go through this data, sift through it, but still, I know we use LLMs for many things, but still I would really urge everybody in the call who wants to try it, try to go through this human exercise, try to drill deep, try to understand your data, so that you can really get to the core of how you can build high quality LLM systems and that you get a feeling for the behavior for some of these models. Okay, I think with an eye on the time, I want to open up the floor to questions for the people that are still here and that might have questions. Changing the layouts. If there are any. Maybe a quick poll to check who wants to use our product if they're not a customer yet. So some of you might know it, but some others might not. We've actually opened up the platform a few months ago, so you can try out with some limitations experimentation in Orq. We know exactly which vendors are out there who offer similar capabilities, but we also know, this is really something I dare to say, that we are sort of the best at this feature. The level of flexibility we have built in is really, really strong. So it takes some getting used to run the first experiment, and I hope this webinar helps. But after you ran your first 2 experiments, you can start running back tests, A/B tests, regression tests, really in a matter of minutes. And if you need to set up the same level of granularity and you need to go through that same data in a Google Sheet, which probably some of you have done in the past, it will take you a lot more time. Yes, a question? Yeah, so tasks versus tools versus agents. This is a bit, I get that the terminology is confusing. So in experiments, we now have sort of a cluster called tasks. And under a task, you can decide to test agents, like we did today, single agents or multi-agents, or you can test prompts. And prompts are pretty much an abstraction of what our deployment feature is. And our deployment feature is a prompt plus a model configuration plus a lot of scaffolding around it, like fallback models, like RAG systems. So you can, by now in our platform, literally test with any configuration that you can think of in the form of an AI feature, you can test with. And for the ones that prefer to work in code and want to even test sort of Orq agents against LangGraph agents or LangGraph agents against Crew AI agents with the evaluators they did test in Orq. We have built a product called Evaluate Orq, which we can quickly share in the chat. Does it answer your question? And maybe last bit to answer your question, Cameron. So obviously a very important component of an agent is a tool. And I think what people underestimate is the quality of descriptions you need to have on your tool call for it to work. So for the ones that are still in the call. So when you integrate a tool, you need to give a description. And oh, the wrong layout again. Sorry. Now it should be better. And it's this description of any tool you use that most of the time when we are debugging agents for our clients, it went wrong here. They either gave no description at all or like 3 words, or they have nothing included in the agent instructions about when this tool should be called. So this seems like, oh, this is just a random field that nobody uses, but this is the field the agent uses to decide I am or I'm not going to use this tool for this task that I'm given. And what I meant with testing tool calls is that you can try with 2 different descriptions on your data set, the same tool with 2 different descriptions. So you can test, okay, actually my tool didn't get hit for some reason with these input queries, but now I changed the description, does it get hit? What are the main users' roles of your product? So I think we see not a fully balanced split. So yeah, all our current clients have full product teams, but the split in terms of personas, I would say, is 60% technical, 40% non-technical. And under that technical flag, you have software engineers, you have data scientists, you have AI engineers. That really, like, how that is split differs very heavily per client, because not every single company already has all of these personas sort of in a single AI product team. So sometimes it's somebody who's formerly a software engineer who acquired all the relevant knowledge to build generative or AI features. Sometimes it's an AI engineer, somebody who has been in the space of AI and ML for much longer than generative models exist. And then 40% non-technical is probably a split of like 30% PMs that take a lot of ownership in building these features. Everything from, like, we have PMs that spend good amounts of their day running experiments. And they pretty much optimize the entire feature, and then they call the engineer, can you integrate this? To state it very black and white, obviously. And then the engineer makes sure the data engineer makes sure that everything is set up in terms of data pipelines, etc. But that we see, and then 10% subject matter experts. We see that probably like 20% of our client base has really a process set up where the subject matter expert, either internal or external, is involved on a regular basis with the product development. Everything from like pre-deployment until post-deployment. But involving these people next to a PM who obviously also takes on some of this knowledge will really help you get to high levels of quality. Like, even you as a PM or data scientist sitting side by side with the subject matter expert and going through this compare view screen or going through this annotation view screen will help you retrieve the relevant qualitative feedback to improve your system. Any other questions? Oh wait, I wanted to share Evaluate Orq. Okie-doke. Well, if there's no further questions, then I think we can close off the webinar for now. I hope you guys liked it. You can send me a message directly. Actually, that's probably the best way to connect. Oh, without the slash at the end. Can I edit this? I'll resend it so you guys can copy paste it. And then I'll share the sign up link. Or Kuldeep, do you quickly want to share the sign up link in the chat as well? So if you really want to go deep on your use case, go deep on your experimentation structure, deep on your evals, feel free to send me an email. Or you can connect with me via LinkedIn, but it's better to do email because then I will respond quicker. And then I think we will send a survey around to get some qualitative feedback as well on our first webinar. Our plan is to host one of the next webinars around, really this CI/CD type of testing. So for anybody who is in the call who is already busy doing this or wants to implement this and wants to know the best practices, you will receive an email and a Luma blast, and you will see the event marketed. I think that is one of the next topics we want to discuss because it needs its own hour of webinar. We didn't want to push it in here. Okie dokie. Then thank you all for joining and thanks for staying, so many people, 20 minutes longer. And have a good day.